We're going to learn about integration of rational functions by partial fractions. If we had to integrate, we had these two different rational terms. We know the antiderivatives, so this would be 4 times the natural log of the absolute value of x plus 3 plus 3 times the natural log of the absolute value of x minus 2 plus a constant. Now, something we need to be careful about, this is the natural log of a function, not just x here, and so we need to consider the chain rule applying, but the derivative of what's inside in both cases here is 1, so we're okay with that. Now, we actually could do something else with this and use log properties and put these as exponents and then combine these under one log. But right now we're just interested in the idea that if I have two rational functions of this form with linear denominators, I can go ahead and find the integral. What if, however, a rational function looked like this? How would we go about integrating this? Well, first of all, let's go back up here and let's combine these under one denominator. If I did that, this one would need an x minus 2, and this one would need an x plus 3. And then the denominator, if we multiplied this out, would be x squared plus x minus 6. And the numerator would be 4x minus 8 plus 3x plus 9. Combining like terms, that would be 7x plus 1. So this is just simply another way to express this integrand right here. So starting with this, if we could break it down into the partial fractions that combined gave us this, then we would have something that we would know how to integrate. So that's exactly what we're going to do. We're going to do the partial fraction decomposition method to get these broken down into the fractions that were added together to give us this. Now, we learned this in college algebra, but it may have been a while, so let's go through the process. So I'm going to take the rational function, so 7x plus 1, over, and I'm going to factor the denominator, so x plus 3, x minus 2, and I'm going to set that equal then to fractions added together, one of which has a denominator for each of these factors. So this one's going to be x plus 3, and this one's going to be x minus 2. We're going to call the numerators a and b since we don't know what they are. Now, I am going to clear this equation of fractions by multiplying everything by the common denominator, which of course would be the x plus 3 and x minus 2. I'm going to write it out this time because I want to remind everybody of the method and why it works. So I am clearing this equation of fractions, multiplying everything by the common denominator. That would cancel all of our fractions. Now if I were to express what's left, I have 7x plus 1 equal a multiplied by x minus 2 plus b multiplied by x plus 3. Now when we have linear factors here, after I get it to this point, I am going to use what we call the convenient x method. This needs to be true for any x, and so I'm going to choose a convenient x that will make this easy to solve. So first of all, I'm going to let x equal negative 3. Now why did I pick negative 3? Because that would conveniently zero out the b term and I'll be able to find a. So substituting in negative 3 here, I would have negative 21 plus 1 equals negative 5a. And putting a negative 3 here will make this 0, so that part is gone. Therefore, negative 20 would equal negative 5a, so a equals 4. I'm now going to go back and repeat this process, choosing another convenient x. This time I'm going to let x equal 2. Choosing that because I could see that that would then make this 0, get rid of the a term, be able to find b. So putting a 2 in here, it'd have 14 plus 1, so 15 equals, that part's gone, and this would be 5b, so b would equal 3. So once we have these two pieces, we go back up to here where we had split this up and we could put those in. So this would equal the integral from a was 4, so 4 over x plus 3 plus b was 3, so 3 over x minus 2 dx. And you can see that's exactly what we had here, and so then we would know how to integrate. First of all, let's summarize. This will be the steps to take if the denominator factors into linear factors. So the highest power on the x is a 1. So let's look at where we start. We're going to factor the denominator for the first step. Then we're going to set the fraction equal to the sum of fractions with each factor as a denominator. We're going to use for the numerators a, b, etc. Then we are going to clear the equation of fractions, and then we will use the convenient x method to find first the a, then the b, then the c, and so forth. And when these are linear factors like this, it's going to be very easy to conveniently find an x to zero out the other terms and be able to find one of these at a time. So let's see this in action, start to finish. So the first thing I'm going to do, I'm going to move down. I'll do the integral in a minute, but this is the partial fraction piece. So I'm going to express this 3x over, I'm going to factor this. So this is going to be x and x, need negative middle term, so negative 4 plus 2. So I'm going to put this equal to these partial fractions, one with denominator x plus 4, another with denominator x plus 2. Had I had another factor here, I would have just done another fraction. So numerators are going to be a and b. Now I'm going to clear this of fractions by multiplying everything by the common denominator, and if you start to end up doing this step in your head and just writing what's left, that's totally fine. I just wanted you to clearly see why this method works, where this is coming from, and so I'm showing you this. So this would cancel with this would get rid of the x minus 4, this would get rid of the x plus 2. Now if we express what we have left, we have 3x equal a times x plus 2 plus b times x minus 4. So I'm going to choose a convenient x to zero out the b so that I'll be able to find a. So I'm going to let x equal 4. Putting a 4 in for x, I'd have 12 equal, putting a 4 here, 4 plus 2 is 6, so 6a. So a is going to be 2. Now I'm going to let x equal negative 2. That would zero out this a piece. Putting a negative 2 in here, I'd have negative 6 equal, that part's gone, negative 2 minus 4, so this would be negative 6b. Dividing by negative 6, b would equal 1. So I can go back up here to my integral now, and I can express this as partial fractions. A was 2, so that's going to be 2 over x minus 4, because here was my piece of that, plus b was 1, so 1 over x plus 2 dx. Now I could do the integration. I'm going to do that right down here. So this is going to equal 2 times the natural log of the absolute value of x minus 4 plus the natural log absolute value of x plus 2 plus a constant of integration. Now I'm going to go ahead and express these combined under one log. So using third property of logs, this can come up here as an exponent. And then I can use the property that says if I have the log in these two terms and I'm adding, I can combine them under one log if I will multiply. There we go. Is it necessary to combine these like this? No. If you gave this as the answer, that's totally fine.